I hope you're all doing well. My name is Stephen Dunfee, and today we're going to be discussing WebRTC, or Web Real-Time Communication. Just as a brief overview, we're going to start out with what WebRTC is and then try to answer why you should care about this technology. Then we're going to discuss very briefly the basic architecture of WebRTC, and after that we'll dive into some of the security and privacy concerns. So what exactly is WebRTC? Well, WebRTC enables real-time voice, video, and data sharing in a web browser, and all of this without the need for browser plugins. Whereas browsers have typically interacted only with one or more web servers, WebRTC allows browsers to exchange media and data with one another directly peer-to-peer. And this has broken the classic client-server paradigm that we're used to seeing, where communication must go through a server before being sent on. So what's the big deal? Why do we care? You might be thinking, we've been doing audio and video communication over the internet for a while now, using technologies like voice over IP, Skype, GoToMeeting, or WebEx, and how is this any different? These are all great technologies, but they also still require physical devices or software packages. And WebRTC changes this model by embedding the ability to send media directly into a web browser. So there's no phone required, there's no download or software install required. The browser makes use of a microphone, speakers, and a camera attached to the computer to send the audio and or the video. This means that a user can communicate with others with basically nothing but a browser and an internet connection. This opens up a lot of opportunities for potentially billions of devices to supporting a browser: PCs, laptops, smartphones, tablets, and a host of other devices from a variety of manufacturers can be made real-time communication enabled. So, in addition to those advantages, WebRTC is also completely free to use. It comes as an open source project, so you can take it and then you can adopt it to your own needs. It's already embedded in most modern browsers, and also it's applicable to mobile devices as well, which opens it up for a lot of other exciting applications. I want to quickly go over a basic simple architecture for the WebRTC model, just to give an idea of the fundamentals of how it works. There are some more complicated protocols at play, but it's not really necessary for our discussion, so I won't go into those. The first thing to note is that in the past, when building voice or video calling applications, they usually required C or C++ coding, which meant longer development cycles and higher development costs. And WebRTC eliminates this by adding a JavaScript layer inside the browser itself, and this makes it much simpler and easier to use for development. The WebRTC architecture involves web servers and browser clients. The web server serves up web applications with embedded JavaScript, and the browser clients, like a PC, tablet, or smartphone, they run the JavaScript application. Traditionally, web browsers have communicated only with web servers, and what is unique about WebRTC is that the web application can now enable peer-to-peer communication between two browser clients. So let's take a look at a simple scenario where Alice and Bob are trying to communicate using WebRTC. The first thing that needs to happen is that Alice and Bob need to exchange network information. So this is done through signaling via the signaling server. And signaling is used to exchange three types of information. The first are session control messages, which are used to initialize and close the communications. The second type is network configuration, which is just the IP addresses and the port information for the devices. And the third type of information are media capabilities, so what codecs and resolutions can my browser handle for this communication. So Alice kicks off a request for a peer connection with Bob via the Signal server. And Bob gets the request and says, yes, I want to connect with Alice. their devices exchange information successfully, and the signal processing portion is complete. And now the JavaScript APIs kick in, and they can begin communicating directly through their peer connection. Okay, so now you have a basic understanding of how WebRTC works. Let's talk about some of the security concerns. I'll start by discussing the built-in securities. There is security built into the peer-to-peer connection between browsers. There's a couple of protocols at play. One is called DTLS, which is the Datagram Transport Layer Security, and another is SRTP, or Secure Real-Time Transport Protocol. These protocols just basically provide encryption, they provide message authentication, and they verify the integrity of the media path between the devices. In addition to this, there's something called identity provisioning, which is involved in the architecture we discussed previously. So when communicating between two users, we want to authenticate the endpoints to make sure we are connected to who we intended to connect with in the first place. And this is done through an identity provider, and this IDP code is loaded in the JavaScript. So using our previous example, Alice would ask the identity provider for an identity assertion. Bob will receive the identity assertion and ask the identity provider to verify the assertion, and the channel will only be authenticated if these assertions match each other. Now, let's talk about the three main sources of concern for WebRTC security. The first is possibility of a malicious web server. So instead of your Signal server, you've got some sort of malicious web server that's involved. So this server might sit in the signaling path of the connection, and it controls the messaging and also controls the client-side JavaScript code. So what kind of impact might this have on users if they're unaware that this malicious web server exists? Another issue is a network attacker, or someone that's gained access, and that person can now observe and tamper with the network traffic. And the third source of concern is the possibility of a malicious third-party JavaScript. So it's possible for hidden malicious code to be injected or included because of scripting vulnerabilities in a website. This malicious code could be run at the same time as the WebRTC JavaScript code and interact with all the APIs that are running. So specifically, for a network attacker, the concern is eavesdropping on your communication. Really, the only way to do this in WebRTC connection is through a man-in-the-middle attack, where the middleman alternates between, again, using our previous example, alternates between pretending to be both Alice and Bob in our previous example. Fortunately, this is pretty difficult to achieve in WebRTC because the protocols we discussed previously, which provide encryption, message authentication, and endpoint fingerprints. Unfortunately, this does not apply to the signaling portion or the Signal server because they're not part of the peer-to-peer protocols. So if a hacker can find a way to compromise the Signal server, they would be able to perform a man-in-the-middle attack in that scenario. Another security concern is leaking network information. So in a browser, you should never have untrusted JavaScript running because they have the ability to do ICE fingerprinting. So it can actually collect all of the local network addresses attached to your device. This could be used for the first steps of reconnaissance on your network environment and possibly open you up to further attacks. And then I'll just touch on some privacy concerns. We talked earlier about the identity provider's role in authenticating connections, and it turns out that this process can be exploited by JavaScript code to automatically generate identity assertions. So, for instance, if you stay logged in to Google or Facebook in your browser, as many people often do, identity assertions can be automatically created and verified for your username and domain for those accounts. So basically it will know your username and the domain name for your various service accounts that you have. So this information can be tracked by anyone that has access to your browser, like advertisers that we have within our browsers, and this is really an information goldmine for a lot of companies. Using this information, companies can set up profiles about users, knowing what types of sites you're visiting, and even more. They can access all of your user profiles across any website or service that you're logged onto, so they can create a profile of any type of service, which could be countless number of services that you have a login to. Okay, so in summary, WebRTC is an exciting and disruptive technology. It's already being used by a number of applications, both in web browsing and mobile, and it's definitely impacting the old school internet voice and media sharing providers. The great thing about it is that it's open source, it's free, has a fairly simple architecture utilizing JavaScript APIs, which are much easier to code and use in various applications. And also with the introduction of peer-to-peer communication via the web, the classic client-server paradigm has been broken down, which also means that the security protocols that went along with that paradigm are not necessarily applicable anymore. So new protocols and security measures need to be put in place to handle this unique networking structure, as well as address the vulnerabilities that JavaScript being used within the browser brings. And that's all I have for today. I hope you enjoyed the presentation, and thank you for your time.